Yeah, hello. Welcome everybody to this talk about generative AI knowledge graphs, how you can bring it together to build better AI agents. And I think this is a very exciting topic, which sounds maybe a little bit abstract, but it will become very clear and tangible throughout the talk. First, not only because I'm a mathematician, I would like to start with a definition because many people in the room might have a different understanding what is an AI agent. So let's take the time and say two things are required so that we can call something an agentic AI. First, capable of autonomous solution development. That means we are not talking about an automated workflow that always is executed the same way. Secondly, can execute tasks independently. And this is very important. It executes a task. It doesn't just give like a chatbot an answer. It does something. And this is a very big difference to, let's say, a chatbot. And before I continue on this, I would spend 1 minute to introduce my company to you. I'm working for a company called Metaphacts. We are into knowledge graphs, as you can see easily here. We are based in Germany since a decade, working on the topic of knowledge graphs and semantic web technologies. Nowadays, also, we're into AI for good reason. Our founder was one of the main contributors to the semantic web, and he started this company to make it easier for people to work with this technology like knowledge graphs and semantic models. And nowadays also we have a new feature, which is agentic AI, because we found out it fits extremely well together. Why? You would see in a minute. First, agentic AI is a topic that is on the agenda of many people already. It has been discussed here a lot. If you screen the internet, what the big consulting firms say, you will get a very consistent picture. This is the thing that will drive the productivity through AI, because we have this execution thing. And there are very high expectations that this is really a very big breakthrough. But still, if you look at this sentence from Deloitte, they say they expect that in 2025 and this year, 25% of companies who are in Gen AI already will do their first POCs on agentic AI. That means it's very early in this agentic AI thing, if you interpret it in a way that I have defined in the beginning. So this is where we are, and let's be a little bit more pragmatic now. You think about a situation, you may be a leader of a team that wants to build an AI agent. And your company, maybe it's a pharmaceutical company, looks like this. And the first question that you have to face is, this agent has been trained, it's a large language model behind, with public information. So if I want to achieve productivity enhancement in my company, how do I do this? Because this agent and the language model doesn't know anything about how we call our IT systems, which people are in our company, our business processes. All this is not known because it's not trained with that information. So how can we do this? Where can the productivity wins come from? So, good question. But the team is clever and found a couple of IT systems that we have where such data is stored. Data catalogs, they contain information about IT systems and data that you have. You have maybe business process management systems, you have vocabulary management systems. There, the information is already available. So, but how do we get it across to the agent? And this is now where the semantic thing comes. So we are at Metafacts the experts for the semantic technologies. And yes, we are using semantic models to inform the agent about the specifics of this company. And this is a quite straightforward approach because this semantic technology has been invented originally to provide a machine interpretable representation of knowledge. And in fact, a large language model understands very well this format that has been defined as a standard in this semantic web. So you will see later that it's really impressive how good the language model can work with such semantic models. Okay, now we know how to do it. We connect the AI agent through a semantic model and the metadata with the specifics of our company. And then we are using, for example, the metaphacts AI agent platform, which can, let's say, plug in a semantic model to learn something new. It already has existing capabilities to develop own solution strategies, and it has a bunch of tools like entity recognition. It can query the knowledge graph, so it knows how to write Sparkle queries. It can do RAG, it can do summarization, and it knows how to create outputs. So it can combine these things to create a solution. That's cool, and then we have prepared for this day today, we have a demo about an enterprise scenario. And the user question we would like to start with is a nightmare in large companies, like really large companies. Which business processes are impacted if we shut down the IT system, which we call Marketo? This can create a lot of headache for people who need to run around and find out, oh, which IT systems? I don't know who to ask. This is where it starts. So imagine we could solve this problem with an agent. And this is what we have here in this demo. I don't know if it starts automatically. Yes, it starts. What you see here is the Metafactory product that was used to build such an app store with a couple of apps. We see the data here. The underlying database that we are using is GraphDB from OntoText. And we have this business process, business objects, IT systems, and so on in the graph. And what you see here is the classical user interface. I said earlier days, we started to make it easy working with knowledge graphs, and this is the user interface that we provide as a standard to do semantic search. It is dynamical filtering that leads you very quickly to the 4 IT systems that would be impacted. This is basic thing. We have a database that creates, let's say, after a query, an output in form of a table. Now we try to do the same with a natural language. We just paste the question here, and we get the same 4 results. The difference to many other systems is that you can here see how did the agent do this. And if I click on this, you see the steps link entity, and then it has created the Sparkle query that at the end created the list of output exactly the same that we had before. No hallucination, because it's the original data set that we look at. So, but that's not all. We have now a second question. List all accountables we have in the company by business process and department. And here the system creates a table of people, departments, and business processes. And I didn't like that in the second column we had the names. So first I asked switch first and second column, and then I had the names in the first column. And then I asked the system, hey, I would like to have make it a bar chart grouped by department. That means it was creating a new data set, put it all into this bar chart, and here we see by department how many accountables we have. So the second thing, is something that is not so easy to be discovered even in the semantic search. In traditional work, we would have happened to go to, let's say, build a new user interface, build a new application to get access to this kind of information. So the productivity win is that we stepped over this in a second by just typing the question, and the AI agent was on the fly creating basically the tool that did this output to us. And this is a very tangible productivity win that we see here through an AI agent. Let me summarize. We have seen that semantic models can be used to inform agents about specific data sets that you have. And it's not only enterprise information. You can basically, any data set that you want to describe to the agent, you can use this approach. Secondly, we have seen the strength of a knowledge graph, which is basically reasoning, connect things, understand how things are working together. This type of reasoning capability we brought to the language model. And in form of the agent, we combine these two things, these two very strong things, language and reasoning. And this is something I think looks for us like a really breakthrough technology. Thanks for your attention.